Hello everyone, I hope you are enjoying this series on data structures and algorithm in JavaScript. I'm committed to ensure that anything and everything which is needed by you to master this concept, I'll be giving you for free on YouTube in best of the quality possible. In today's topic, we're going to get started with recursion. We'll start with the solid foundation of recursion, solve few problems so that we are all set on making use of recursion for solving the complicated topics. Get started with the topic called as recursion today, right? So in this topic, we're going to get started with the topic called as a recursion. So sir, if I go and talk about recursion as such, right? If I go and talk about the recursion. Recursion is a concept which you will go and make use of at multiple places, right? As we make advances and we go into the advanced data structures and algorithm, like for example, we go and talk about the divide and conquer algorithm. When we start something called as trees, when we start something called as graph, when we start something called as a dynamic programming, these are considered to be one of the most complicated concepts, or the concepts on which the Google, the Facebooks, these likes of the companies are habituated asking questions. If you have a good understanding of the recursion, sir, you will be able to solve all these questions with great ease. But if not, then you will have a lot of challenges. Now, recursion as a topic, when I go and say, just like the time complexity that we have learned so far, people take recursion as for granted. Many of the times when I go and ask people, do you know recursion? They all say that yes, we know recursion. But trust me, 90% of the people who are using recursion are using only 30% of its concepts. And I'm telling you, and I'll prove you by the end of this session what I'm trying to tell you. Recursion in itself is a very powerful concept. And if you know it well, many of the questions which, let's say that if I go and solve it using the for loop, while loop, it might, I'll be able to solve by writing pages of code, more than 200, 300 lines of the code. Using the recursion, I can do it in just 2 to 3 lines. I'm again repeating, recursion is such a powerful concept. Many of the times if you use it effectively, the same question which you solve in for loop by writing 200 lines of code, you can just go and solve it in 2 to 3 lines of code. And I'll prove you in the class itself what I'm trying to say. So in nutshell, recursion is such an important concept I would like to introduce in the beginning itself, so that you have a solid foundation, and then using recursion when the future topics comes up, every question that we go and try to solve, we'll try to see from the perspective of a recursion, can recursion be applied there? Fair enough? So I think we have all understood that what and why we should go and learn recursion, because this is going to be a very crucial tool which will help us solve the complicated problems as we move ahead. So for that, a solid understanding is very much needed. So now let's get started and understand what this recursion is in a very simple manner, right? So if I go and talk about the recursion, right? Let me do one thing. Let me go and open my Chrome browser. I hope you are able to see my screen. We zoom out a little and let me go and type recursion. Can you see here when I go and type recursion in the Google search, it is saying, did you mean recursion? And if I click on this, it again presents the same screen. If I go and click on this, the same screen is coming again and again. Can you guys give it a try? Pause the video and try in your browser. When you go and search for recursion, you see here, and when you click on this, the same thing is repeated. So in very nutshell, in a very basic meaning, the meaning of recursion is repeating itself. The meaning of the recursion is when you repeat yourself. It's like a Bollywood movie was there, Karthik calling Karthik. So when the Karthik called Karthik, it's typically an example of a recursive call. And in the world of programming, when it comes about the code, right? When we go and define a function, let's say that I go and define a function called as function print. And inside the function, if I call this print again, this typically is an example of recursion. What is recursion? A recursive function is a one which is called inside another. Let's try to go and write the code itself. So if I go and open my code here, right? And let's say that I go and define a function called as function, and I go and call it as print, right? And here I go and write print hello world, fair. And if I go and call this print here itself. So now inside this function, this, since I have written this function body, right? Inside this function I have written this function body called print. This is an example of recursion. Now, a question for you people, if I go and execute this function called print, what will happen? If I go and call this function print, what will happen? So if I go and run this node, so I'm using a VS Code editor to run this JavaScript code, and I have installed node.js. So if you want to do the setup, what you need to do is that you need to have the VS Code installed. It's very simple. I would not like to go and explain you that. Just Google search and find it out. You have to install VS Code. That's number one. And number two that you need to do is that you have to install node.js from their official site. Both of them are very simple, pretty easy and straight things, so I am not going to spend much time there, and I want you people to do this. Now, if I go and run this node rec underscore part1.js, right now I have not called it. Let me go and call this function called as print. And if now if I go and call this, and I see you it prints hello world, and then it is calling the maximum call stack size exceeded. Why is that happening? It is happening because when I go and call the function like this, if I go and copy this here on my whiteboard, right? Since I go and call this function print, it called the function print, and then again it calls, right? So for example, the print called, inside the print the another print called, inside the print the another print call has happened, and it keeps on happening till infinity. And we know that every execution that happens on a computer will take some space, some memory, some computation. So eventually after printing, it will go and fail, saying that all the space has been occupied. So when you go and write a recursive function like this is similar as the infinite loop. This is same as writing a infinite loop. So sir, what we have understood as out of this is that, let me go and write this. We have understood that what is a recursion? Recursion function or recursive function is the one in which you go and call function inside a function, right? This is what typically a recursion is. But if you go and play this recursive form where a function is called inside the function in this pure form, as we saw in this example, this might lead to a situation of the infinite loop. I'll just tell you a very the relevant story. When we used to be in the college, when I was in the first year, we used to write a very simple but very effective virus. And how do we write it? We used to write it in the same way, right? So the code which I have written as of now, right, on your screen, this is a form of a very simple and effective virus. Why I'm saying that? Why am I saying this? Because this code which you see on the screen right now, typically is a form of a virus. So what we used to do is that we used to write a recursive code which goes for an infinite recursive loop, and then we used to zip it with some fancy name, and then we used to, in our local area network, we used to broadcast this to all the computers, to all our friends. The trick was in giving a tricky name, right, a catchy name, so that everyone, and you understand what kind of name we would use to give, so that everyone is forced to click on that item and open it and see it. As soon as they used to click it, these recursive call starts running in the background, and ultimately it takes all the memory of the system and the system used to shut down, right, or it stops responding because all the memory has been used in running this infinite loop because of this recursive function. So when you go and write a recursive function like this, typically it will go for an infinite time, and typically finally somehow it will go and terminate. As you can see here in this output here also, as you can see here, it has just failed down. Maximum call stack size exceeded. I am getting this error call as a maximum call stack size exceeded. Fair enough? Cool. So in order to write effectively recursion, what happens if you have to go and write an effective recursion? Typically, any recursive code that we go and write going ahead, any recursive code, simple problem, easy problem, complex problem, every recursive problem should have the three things. A, call as the base condition or the termination condition. Every time you write a recursive code, you have to ensure that there has to be a certain condition at which the function should exit, the function should stop executing. Because if there is no condition at which the function stops, it will go on repeating itself again and again, which will lead to the infinite loop and your system will crash down. So every recursive function that you write, you have to make sure that there is a base condition or a termination condition at which the function stops. That's number one. What is number two? See, if you are writing a recursive function, you are trying to solve some problem. And to solve some problem, you have to have the logic. So there has to be a part where you have written some kind of logic. So every recursive function that you go and write has to have some kind of logic. And the third, which is the third part, I go and call it as C because I've been using ABC. Right? The third important part is that you should be able to call the function again. So every recursive function should have a recursive call. So going ahead, as and when we solve many problems, almost every problem at the core of it, if you go and see, every recursive implementation that you go and do will have three parts: A, B and C. A is the base condition or the termination condition, B is the logic part, and C is the recursive call. Let's try to see this with the help of an example code. So for example, if I go to my code, let's say that my problem statement is, let's say that I have array of the numbers 1, 2, 3, and what I want to do, I want to go and iterate over it and print all of them. I want to print all these numbers, right? This is my problem statement. Now if I have to go and solve using recursion, if I have to go and solve this problem using recursion, let's try to see how we can do it. So I go to my VS Code here, and in this, let me go and comment this part of the code. This part of the code has been commented, and now let's write the code for this. I'll just go and clean this also. Clear, perfect. So for writing the code, what we do is I go and call it as function, and I go and call it as print. You guys please write the code to print all the elements of an array. I have to go and pass the array, and then I have to go and set the starting index. Now I just told you, whenever you have to write a recursive function, we have to write three things. We have to write the base condition, we have to write the logic, and we have to write the recursive call. Right? This is what we have to go and do. Let me go and copy this and paste it here, and let's try to see that how we can do it. So any recursive code that we have to go and write, sir, right? Any recursive code that we have to go and write, we have to write the base condition, we have to write the logic, and we have to write the recursive call. Correct? Now if you see here, this is my 1, 2, 3, right? This is my array which I want to go and pass, and SI starting index will be equals to 0. Let's say that index starts from here, 0, 1, 2. Right? The base condition says that when I should come out of this print function. So I know that I have to print this. So till the time SI value is 0, I have to continue. I have to print this, SI value 1, I have to continue. Print this, SI value equals to 2, print. When SI value goes beyond this, when SI value becomes equals to 3, then at that time I should terminate. Fair enough. I have to go through each of the index of this array, 0, 1, 2. When I go beyond 2, then I have to come out of this array, right? So what should be my base condition, termination condition? I should go and say that if starting index value becomes greater than or equals to array dot length, right? What is the length? Array dot length of this value will be equals to 3. So I am saying if SI value is greater than or equals to array dot length, in that case don't do anything, just go and return. You have to return out of this function. Fair enough? So this will be the base condition. I am giving the condition at which I have to come out of this function. This is my base condition. What is the logic? Logic is the problem that I am trying to solve. What is the problem I am trying to solve? I am trying to solve the problem that I have to print all the elements. So when I am at ith SI index, I have to go and print this element. So what I'll go and do, I'll go and say that console dot log, and I'll go and say that array SI. So that's why I go and print the SIth index element in this array. And then I have to call this function recursively again. So if I have to go and call function recursively again, I go and call it as print. I go and pass array, and then if you see here, I have to go and increment SI plus 1. So see here, in very simple words, I have written this base condition da 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 da, console logic, this is the logic, and this is a recursive call where I am calling this function again by incrementing the starting index by 1. Let's try to write this code and see if it works. So if I go back to my VS Code and write here the base condition, which is if SI is greater than equals to array dot length, in that case I should come out, so I will go and say the return. Return nothing, right? I just come out of the function. Logic is to print, so I go and say that console dot log, and I go and say that array I SI. Fair enough? Let me go up. Right? And then in the recursive call, I have to go and call this function again. So I go and say that print, and I go and say that array SI plus 1. So if I go and call this function now, function print array SI, base condition SI, da 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 da, console dot log. If I go and run this function now, I go and call this as node recpart1.js. Oh, I have not called this function, so let me go and call this function print, and then I go and pass 1, 2, 3, and then I go and pass starting index at 0, and I run this. If you see here, it's working fine and able to print elements 1, 2, 3. So this is my final code that I have written. Let me go and copy paste this and see here that what we do here. So the code that we have written, the first recursive code that we have written looks something like this. This is our first recursive code. As you can see here, the first one is the base condition. This is the console logic, and this, and if I go and pass print 1, 2, 3, and I go and pass the starting index value equals to 0, this will first print 1, this will first print 2, then it will print 3. Okay, so we have written the code now. The next thing that we need to do is that understand that how this execution happens. Going ahead, almost every problem that we do, even if I am not doing in here in the recording just to save some time, your duty is that you should do a dry run of it. Every time in the interview also you solve a problem, the interview will ask you to dry run. Doing the dry run of a problem helps you eradicate many of the bugs yourself. So it should be a practice that every time you're writing a code, you should try to dry run before submitting it. So let's say you do a dry run of this. So let me go and call this function. Let's say that I go and call the function like this, right? So the first time when the function is called like this, what happens then? When the first time the function is called, the value of array which is passed is equals to 1, 2, 3, and starting index value passed is equals to 0 perfectly. So I came here, starting index value is 0, array dot length value is how much? This is 3. So I don't go inside this, I came here, I go and print this value is equals to 0, so I go and print element at the 0th index. So first element gets printed, which is equals to 1, perfect. And then I move here where I go and call this function recursively. So from here, the second time the function is called. The second time when the function is called, now let me go and remove all of this. Second time when the function is called, the value of array at that time remains same, which is 1, 2, 3. But the starting index value was incremented to 1. So starting index value became equals to 1. So I'm second time inside the function, si value is equals to 1, array dot length value is equals to 3. So it doesn't holds true. It comes here and prints the value at the first index. What is the element at the first index? Value is 2, so it prints 2. And then again comes here. So from here it goes to the third time to the next recursive call. In the next recursive call, again the array value remains the same, which is equals to 1, 2, 3. And starting index value is equals to, it has been incremented by the previous, so value has become equals to 2. So again when it is getting executed, the next time the starting index value has come as 2, this value is 3, doesn't hold true, so I go and print the element in the second index. So it goes and print the element in the second index whose value is equals to 3, and then I come here. Fourth time the function is called. When the fourth time the function is called, the value of array remains the same, which is equals to 1, 2 and 3. And what is the value of starting index? The starting index value has become equals to 3, right? So I am here and this is 3 and this value is also equals to 3. So this matches and I go and hit the return condition. So at this point I hit the base conditions. So when I go and hit the base condition, what happens? The control moves from 4 to 3. From 3 I go back to step number 2. From 2 I go back to the step number 1 and then finally I terminate. So the point that I am trying to tell here is that in the case of recursion, execution stops at the point where it started, right? So if I try to explain you what that means, in the case of for loops or while loop, what happened? The execution is always in single direction. For example, you are at the step 1, then you will move to the step 2, then you will move to the step 3, then you will move to the step 4 and then you stop. So you come from here, here, here and then you are done, then stop. So it's always a single direction execution. Whereas in the case of recursion, what happens? You go from the step 1, you go to the step 2, you go to the step 3, right, like this. Let me write in a better way in another color. Let's say step 1, from step 1 you go to the step 2, step 2 you go to the step 3, step 4 you go to the step 4 and here you hit the base condition. So when you hit the base condition, you don't stop there. You also come back to the step 3, step 2, step 1 and then finally you terminate. That's the beauty of recursion is. Recursion moves in both the directions. So you can have the logic here and you can also have the logic value returning back. Since it traverses twice, the potential, the power of the recursion becomes twice as much as the loop. Now what I said, let's try to understand with the help of an example. Okay, so now let's continue. So I have this code that I have already written. Let me go and copy paste it and put it here. Right. So this is a code which has written, right, and in this code if I go and pass print 1, 2, 3 and I pass 0 index, right, then it is going to print elements like this 1, 2, 3. Now I have a question for you people. What change I do in this code, the code section that you can see here, what change I do in this code minimal change, only rearrangement. What code change or rearrangement actually, not code change also, rearrangement that I can do in this block of the code which is in the left, so that the same function starts printing first 3, then 2 and then 1. You don't have to make any code changes, you just have to rearrange these lines of the code. What change can I do so that the same function start printing in the reverse order 3, 2, 1? Can you guys give it a try? Just pause the video, put that into the comments if you are able to solve this. The only change that we might have to do is that I'll have to bring this print first and this logic after this. If I go and do this, it will start printing in the reverse order. Let's try to see that. So if I go back to my code, and the code, if I go and write this, I bring this below and run the same code now, you will see that my output is 3, 2, 1. Just changing the order of the logic and the recursive call is getting me data in the reverse order. Let me copy this code and let's try to write on this what has happened actually. Let's try to copy this code and let's try to write on this. So this is the code, fair enough. And I go and call this function like this, print, and then I go and pass 1, 2, 3, and then I go and pass starting index is equals to 0. Fair. First time when the function is called, array value is equals to what? 1, 2, 3, starting index value is equals to 0. Now I came here, starting index value is 0, this value is equals to 3, I don't go inside this, I came here. Now when I came here, I have called the recursive call. I don't do anything, I have directly called the recursive call print. Print is the name of the function, I call the recursive call. So when I go and did the recursive call from 1, I went to the second time. Here array remains the same, 1, 2, 3. Starting index value becomes what? Starting index value becomes equals to 1, it got incremented by 1 value, so SI value has become equals to 1. So the second time when it is getting called, SI value has now become equals to 1, this is already 3, does not holds 2, come here and call the recursive function again. So the next time again the recursive function is called the third time, which is array, remains the same, 1, 2, 3, starting index value has become equals to what? 2. So I go and make the starting index value as equals to 2 and this is equals to 3, does not holds 2, I come here, again there is a recursive call. So in the recursive call, I go and call it for the fourth time, array remains the same, 1, 2, 3, starting index value has become equals to 3. So the next time starting index value is equals to 3, this value is also equals to 3, holds 2, hit the base condition. So the base condition is hit. As soon as the base condition is hit, what happens, sir? From fourth it will go back to the third step. When it goes to the third step, I was here and at that time value of SI was what? 2. I'll go and execute the next step which is left. So the next step which I go and execute is console log, and at this point SI value is what? Equals to 2. So the element of the 2 index is what? 3. So it goes and prints 3. And after printing this is all done, so I again go back to the second step. Again when it goes to the second step, it is here. At this point the value of SI is what? 1. So if I go back to the next step, I have to go and print the element at the 1 index, so I go and print 2. And after doing this, I again go back to the first step, and I go to the first step, again I am here, SI value is equal to 0, so I have to go and element the 0th index, I go and print 3, 2, 1. And that's how I am able to go and print. So if I go and analyze this problem, sir, if I go and analyze this problem, in this case what is happening? I am going from the first step to the second step, I am going from second to the third step, I am going from third to the fourth step, and there the base condition is hit. And when I am returning here, I am printing this console dot log. From here I am printing the console dot log. And returning here I am printing the console dot log. Right, and then I terminate. And hence I am able to do it in the reverse order. So one of the theory that you can take it from here is that in the case of recursion, If you go and write like this, first base condition, second you go and write the logic, and third you write the recursive call. In that case, the whole flow goes like this. Step 1, step 2, step 3, step 4, base condition, and then you return, then you return, then you return. When you write logic before recursive call, so logic will be written here while it's going down. This logic will be applied while going down. On the other hand, if I go and write one base condition, which has to be in the beginning, and then followed by the recursive call, and then follow by the logic. If I go and follow the sequence, in that case, if it is 1, 1 goes to the step 2, 2 goes to the step 3, 3 goes to the step 4, and then I go to the base condition. So when I'm returning, my logic will be applying here. So when you go and write the logic after the recursive call, you are actually operating in the reverse way. And now in the more complicated problems, where you have, let's say that you first go and write the base condition, then you write the logic 1, then you write the recursive call, and then you write the logic 2. Let's say this is the situation. In this case, the whole flow might look like this: 1, 2, 2, 3, 3 to 4, and then you have a base condition that you go and write, and then you go and return from 4 to 3, 3 to 2, and 2 to 1. Right? This is the place where your logic 1 applies, logic 1 applies, logic 1 applies, and this is a place where the logic 2 applies, logic 2 applies, logic 2 applies. Fair enough? So in the most of the complicated situation, you will use base condition, logic 1, recursive call, logic 2, and that's how it works. So I feel we have got some good hold on the basic concept of the recursion. If not still, please pause this video, go back. That's the beauty of the recorded content on the YouTube. We can always go revise and come back. Now let's try to solve few problems to master these concepts, and then we talk about that how in the recursive function we can find the time complexity in our next video, which will come up. Let's get cool. So let's get started and start solving few of the problems. The first problem says that factorial calculation. Write a function to calculate the factorial of a number using recursion. Now what does that mean? What is the meaning of a factorial? Factorial means that, let's say that I write 5 factorial. This is the symbol which indicates the factorial. It means that I have to keep on multiplying from 1 till 5. 2, 3, 4, 5. If it is 9 factorial, I can go and call it as 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Typically, I can also go and say that this whole thing as 9 into 8 factorial. Right? So let's say that if it is 7 factorial, one of the way of representing is 7 into 6 factorial. I can go and represent 6 as 6 into 5 factorial. I can go and represent it 7 into 6 into 5 into 4 factorial, and this typically will look something like 7, 6, 5, 4, 3, 2, 1. Right? This is how typically the 7 factorial looks like. Right? The value of 0 factorial or 1 factorial is equals to 1, and we don't we don't create factorial for the negative numbers. We don't go and find the factorial for the negative number. So based on that, let's say that if I have to go and find the factorial of n factorial, I can go and call it as n into n minus 1 factorial. Right? N factorial is, so if I have to go and solve this problem n factorial, I can go and multiply n into n minus. So this is a smaller problem. So with this we get a hint that this problem could be solved using the recursion. So let's start solving using the recursion. That how do you like to go and do it? So let me go and directly go to my code and understand this. So I'll go and comment this up and then bring here function factorial, and I have the number now. Now I know that anything that I go and solve using the recursion, the first should be the base condition, boss, right? The first should be the base condition. What should the base condition here? I know that if the number value is equals to 0 or number value is equals to 1, the factorial value will be equals to the number itself, 1 itself, right? Will be equals to 1. So I know that. So I can simply go and write the base condition is that if number is equals to 0 or number is equals to 1, in that case I should go and return 1. That's the value. And if that is not the case, then what I need to do is I have to multiply by this number and then I have to go and find the factorial of the previous number. Fair enough, right? Can you see here? So in this factorial function what I have done, this is my very beautiful question, right? So this is my number. I know that base condition number value is equals to 0, number is equals to 1, I should go and return 1. Else, whatever is that number, I know that if it is 10 factorial, I can go and write it as 10 into 9 factorial. So this is what I am saying. This number, whatever is this number, I go and multiply with the factorial of the number minus 1, and whatever that is done, this has to be returned. This has to be returned. Let's try to do the same thing here. I just have to go and pass here return. Let's run this and see if it works. I go and call it as fact and I go and pass 5. If I go and run this, print not console.log, let's go and run this. The value is 120, correct? 5 factorial, if I go and find this, 5 factorial, 5, 4, 3, 2, 1, this value is coming out to be 120 and my code is also returning me the right results. Let me quickly do the dry run of this. I'll do the dry run of this and the remaining one I would expect you people to do it. Let me go and copy this. Right, and I go and put it here on my whiteboard. Let me put the code here. Okay. Now I go and call this as fact. Let's say that I have to go and find the factorial for 4. So the first time when the function is called, the number value is equals to 4, right? And then what I go and do, here I go and multiply number value is 4 into, and then this is the recursive call the second time. Second time when the recursive call happens, the number value has become equals to what? Number value has become equals to 3. And then it comes here 3 into, and then the recursive call happens third time. Number value has equals to become equals to 2 and writes 2 into, and then you get a recursive call. Fourth time number value has become equals to 1 and this is the base condition, right? And from here you come back. When you come back you return the value as 1 and this value is equals to 2. From here you return here the value is 2 and this value becomes equals to 6. From here you return 6, this value is equals to 24, right? And from here you return the final value as 24 itself. So this is how we go and run this code. Let's move quickly to the next question. Sum of the array elements. Write a function to find the sum of all the elements in array using recursion. So basically it is saying that you have been given an array that looks something like this. 1, 2, 3, 4 and 5. And I have to go and find the sum of all these elements, 1 plus 2 plus 3 plus 4 plus 5, and the value should be equal to how much? 5 plus 4, 9, 12, 14, 15. The answer is 15, right? So I have to go and solve this problem. Now for doing this, right, every time you write a function, the 90% of the effort goes in that how do we go define the function itself. If you are able to define the function well, half of your work is done there itself, right? So if I have to go and find the sum of this function, one of the things that I need to do is that one of the arguments will be this array itself, that's one, and the second should be the starting index, right, the index. So when it is here I have to keep on summing, when I am here I have to keep on summing. When I go beyond this, I mean that I have added all the elements and I don't need to return any other element. Fair enough? So thinking this, let's go to my code and try to write the code. So let me go and comment this code as well, and let's try to write a new code. So I go and call it as funcs, and sum of the array, and I go and pass array starting index. Just like the previous question, if I have to go and find the base condition, what will be the base condition? The base condition is, or the termination condition is that when I have went beyond the last index. So when I go and say that if starting index is greater than equals to array dot length, then in that case I should go and return 0. Then the starting index is greater than equals to array dot length, then I should go and return 0. Otherwise, what I should do is that I should go and return the element which is there here, array at the starting index, plus sum of array, and then I go and pass here array, comma, starting index plus 1. What I go and do here? If you see here, this is my base condition. So when I go beyond the last index, I should go and return 0. Otherwise, whatever is the element at this present, and I go and find the sum of the remaining elements. What I am trying to say is that let's say that I am here 1, 2, 3, 4, 5. In the beginning, I have to find the sum of this entire range. And the beginning SI value is equals to 0. So at this moment, I say that I know this value is first. So I go and say that first, and then try to go and find the sum of the elements of 2, 3, 4 and 5, which I am trying to do it through the recursively. Let's try to clean this and run this code. So if I go and do this print console.log, and I go and say that sum underscore array, and then I go and pass 1, 2, 3, 4, 5. Starting index value is equals to 0. If I go and run this, the value becomes also 15. So I am able to run this code, but what I want you people to do is, I want you people to do the dry run of this. I want you guys to do the dry run of this code. Please do the dry run. It will help you go deeper. Even if you know that simple, asan, I know this, still I want people to give a try. Please do the dry run of this question. Fair enough. So I believe we have done a basic context on the recursion. The next thing that we'll do in the next video is that we'll understand that how for the recursive problems we find the time complexity and space complexity, and then we'll move on little more advanced features, the types of the recursion, few additional advanced problem, and then going ahead, every topic that we go through, every question that we go and solve, every problem that we understand, we'll try to solve both iteratively as well as recursively. Thank you.